In this last example for section 13.3, we are given a function f of xy equals 2x squared plus 2y squared plus 3xy minus 5x minus 2y. We want to find all the values of x and y so that the partial with respect to x equals 0 and the partial with respect to y equals 0 simultaneously. Now I am going to show you something on the graphing calculator that you may not have ever done. So have your calculator handy, and I'm going to show you when we get to a step how the calculator can be a little bit of a time saver here. First of all, we're given our function and we want to find out where the partials are equal to 0 simultaneously. Let's find the partial derivative of the function with respect to x. Treating x as a variable and everything else is a constant. The derivative of 2x squared is 4x. The derivative of 2y squared, when we treat y as a constant, is 0. The derivative of 3x is 3 times the constant y, so it's going to be plus 3y. And the derivative of minus 5x is minus 5. And the derivative of minus 2y, treating y as a constant, is 0. So our first partial with respect to x is 4x plus 3y minus 5. We want to know when that equals 0. What's the value of x? We also want to find the partial derivative of the function with respect to y. Go back to the function and you're going to treat y as a variable this time and treat x as a constant. The derivative of 2x squared, since x is a constant, is 0. The derivative of 2y squared with respect to y is 4y. The derivative of plus 3xy, the derivative of a constant times y is the constant, so that's going to be plus 3x. The derivative of minus 5x, 5x is a constant when we take the derivative with respect to y, so that's 0. And the derivative of minus 2y is minus 2 equals 0. We want to find out where these partial derivatives are equal to 0 simultaneously. Now we have two equations and two variables. You can solve this system of equations by using the substitution method. You can use a graphing method, you can use the elimination method, or you can even use a matrix method. And that's the method I'm going to show you today. In order to use the matrix method on the calculator, for solving a system of equations, here we have two equations with two unknowns. You could also do this with 3 equations and 3 unknowns if you were working out a problem like that. So it does have to be a linear matrix, so it must be set up in the form of ax plus by equals c, and let's use dx plus ey equals f. If you have a system of equations set up in this way, we can assign a matrix using only the constants. Our matrix is going to be a matrix with 2 rows and 3 columns using just the numbers, not using the x's or the y's. This is going to be our matrix, and what we want to do is use a command on our calculator to reduce the row echelon form of this matrix so that we can determine the solution. I'm going to take you through step by step, going slowly, but once you get the hang of this, this ends up being a very quick method for solving systems of linear equations. I do want to make the form of these equations so that we have the x and the y all lined up and the equals and the numbers. So by taking the first equation, I'm going to rewrite the first equation as 4x plus 3y equals 5. What I did is I just added 5 to both sides of that equation. And then the second equation, writing the x term first, I get 3x plus 4y equals, add 2 to both sides, and you get 2. So the matrix that you're going to use is simply the numbers that are in front of the x and y and the numbers that are on the other side of the equal sign. So we want to build a matrix, and then we're going to reduce row echelon form, RREF, the matrix that has these coefficients 4, 3, 5, and 3, 4, 2. Solving this system of equations by reducing the rows here, we're going to end up with a matrix with 1, 0, and then some number here, 0, 1, and then some number here. So let me show you this part on the graphing calculator. Now with your graphing calculator, you're going to first build the matrix. I have the calculator showing, and I'm going to show you the history of all the buttons that I push so you can refer back to this. Once you get the hang of this, this ends up being very quick. First you need to build a matrix. On this TI-84, to find the matrix button, to press second and then that matrix button. You end up with the names of all the matrices that you can build. We have to first edit the matrix. So I'm going to use the arrows to go to the edit menu, and I'm going to choose to edit matrix A, which is number 1. Now you have the ability to change the number of rows and columns. This has 2 rows, so type in 2 and enter, and it has 3 columns. Type in 3 and enter. So you see there are 6 spaces, and in those 6 spaces we're going to be putting the numbers here, 435, 342, and these are the numbers that we got by looking at the system of equations. We set each of those equal to 0, rearrange it a little bit, and just use those numbers. We're going to type in each number and then press enter after each one. And double check your matrix, 4, 3, 5, 3, 4, 2. Now I'm going to quit out of the matrix menu by pressing second and quit. Now I'm back to my home screen, and I want to find the command to reduce the row echelon form of this matrix. And I find that by going to the matrix menu, pressing second, matrix, and then I'm going to go to the math menu. You first edit the matrix to build it, and then you could do the math with the matrix. So I'm going to go to the right, and I'm going to scroll down until I see the command to RREF. Now there's an REF, that's a row echelon form. That's not the one you want. You want to keep going down. In this case, it's the letter B for reduced row echelon form. If you have taken matrix theory, then you probably recognize that command. If you haven't taken it, this is something that you can take in future classes, reduced row echelon form. They'll get into that in more detail. So I'm going to go to that command, reduce row echelon form, and then I need to tell it to reduce the matrix that we built was matrix A. So I'm going to go back to the matrix menu, second matrix, and I'm going to choose the name of the matrix that I want to reduce, which is number 1, and I can close the parentheses. So it'll take whatever's in matrix A and reduce it into this echelon form, and we get 1, 0, 2, 0, 1, negative 1. That ends up giving you the solution to the system of equations. So back to my example over here. The solution that we found is the matrix 1, 0, 2, and 0, 1, negative 1. Now, just how I left out the x's and the y's to build this equation, I can put the x's and the y's back into this equation here and show you what our solution is. This is the same thing as 1x plus 0y equals 2, and 0x plus 1y equals negative 1. So this simplifies to x equals 2 and y equals negative 1. So again, you take those numbers here from the matrix, And it ends up being that these last two numbers are your solutions, your x and y. So what we've done here is found the values of x and y so that the partial derivative of this with respect to x and y are both 0 simultaneously.